Hey guys, I've been getting requests about what's going to be on the AP Calculus exam for this year. Yeah, they asked me if I can do one from 2020. But you know what? I looked around and there's nothing in there. I don't think they've released any of those questions. Now, last year I did see them because I was able to check for the questions from my students, but I don't think they were released at all. So that's going to be a toughie. But in any case, guys, remember 2020 was an oddball. Okay, so that we shouldn't use that as a frame of reference. Well, this year they did say that they're going to go back to the regular format, so it's going to be a full test, multiple choice. Now remember, guys, this is what's going to be on the test. Okay, now these are the FRQs. Now you got to remember that 30% of the test is about integrals. Okay, and the fundamental theorem of calculus and everything that have to do with that. Okay, so a third of the test, that's a big chunk. Okay, now there's a few questions that you're gonna see. Okay, you're gonna see 6 of them, right? I believe it was 2 with calculator, 4 with free response. So you're gonna see this, okay, guys? You're gonna see a graph analysis question. Every single year on the AP exam, this question has always come up. Why? Because it's fundamental, has a fundamental theorem of calculus. You're gonna see it. Another one you're going to see is what's called rate accumulation. Something comes in and something comes out. You're going to see this. These two are fundamental to calculus. Okay, I promise you're going to see that. Go back and look at my other videos to help you just kind of see. They always ask the same thing. Always ask the same thing every single year. So once you see it, and my goal is to hopefully open your eyes to be able to understand what's going to be asked of you. And once you understand it, man, the test is so much easier. You're also going to see particle motion. I see this a lot. I'd say about 90% of the time. And then the other one is area volume. Now, last year, there was no area volume. Okay? But this year, I'm pretty sure it's going to be on there. And you also get a differential equation. And implicit rates, this guy, it's like an oddball. Sometimes you get it, sometimes you don't. Same thing with differential equations. And if I'm not mistaken, the last time they had it was 2018. I don't know if they had it in 2019. But my guess is they would probably have it in 2019. I'm sorry, 2021. 2018, I'm trying to check here. Okay. No, they had a differential equation in 2018, and I believe also in 2019. So last year they didn't have one, so I would just be ready for that. Now, I've done videos on most of these, except I don't think I've done area volume. So I want to take some time today to do an area volume one, okay? I'm going to take this one from 2019, and I want you to see a couple of things, okay? Remember, we got to study our not our enemy, but our opponent. Now, there's a couple of things they're always going to ask about this, okay? Because I know you've learned the washer method, the disk method, cross-sectional area, finding the volume using cross-sections and all that good stuff. But when you get a graph like this, you got to know, okay, they're probably going to ask me something about area volume. Usually the first question is about area. That's easy, right? You just take the top function minus the bottom function. Now, this question in 2019, it looks like it was not a calculated question, so I'll try to do the best that I can. I only have a limited space, but we'll do the best that we can. So it says find the area of R, and you got these functions here, right? The top function minus the bottom function. That's all we're doing. What's the top function? Really, it's kind of hard to tell, right? Well, this is the parabola right here. Okay, you can plug in 0 here if you want, right? And you can see it'll be 0, 1, 2, 3, 4 right here. So the top function is h of x. The bottom function is g of x. And then dx. Boom. Okay, from where to where? Well, we're going to go from 0 to 2. All right. And that's pretty much it. Now we just got to go ahead and evaluate it. And I'll try to do as much as I can. So h of x is 6 minus 2. X minus 1 squared. Okay, and that's minus, and then we have this guy over here. So be careful with those double negatives, okay guys? 3 cosine of pi over 2x. Okay, and this is the integral from 0 to 2. Okay, close that guy off right there. All right, now we got to go ahead and see if we can clean this up just a little bit before we do the antiderivative. So let's go ahead and do this guy here. It'll be the integral from 0 to 2, 6 minus 2 times x minus 1 squared. This becomes a positive 2, and then minus 3 cosine of pi over 2x. Alright, and that's dx, just like that. Alright. So, what we have to do, guys, by hand is we have to do the antiderivative of all this stuff. And sometimes it kind of gets a little scary, doesn't it? But just take it one step at a time. One step at a time. Now, you got to bear in mind that we're pressed for time, right, for this type of question. And this is kind of interesting because normally the first question is like 1 point and you're done. This is very, very simple. But for some reason, this guy, they made the first one be worth 4 points. And that's okay. But the antiderivative of 6 becomes what? 6x. Alright? And then minus. Now this guy here, you can do u substitution, but if you can see it, if you do u substitution, alright, let me see here if I can do this. If we let u equal x minus 1, that means du is equal to 1 dx. Nothing really happens. Okay? So you can just go ahead and take the antiderivative as it is. But for those of you that are struggling with this one right here, okay, so it's 2, so instead of x minus 1, we're going to put u squared, right? And then the antiderivative becomes 2/3, okay, u to the third, like that. And then what? We plug in back that u in there. So this guy's going to be minus 2/3 x minus 1 to the third power. Alright? But sometimes you can kind of see it straightforward and it, you can do it in your head. Alright guys? And then that's this part right here. And then the 2 becomes what? It becomes 2x. Okay, the antiderivative. So that's a minus 3. Now remember, the 3 is a constant. So think about it. If we had 2 integrals here, like if we had an integral here, right? We can take out the constant, right? Take this guy out here. So just cover them up. What's the antiderivative of cosine? Well, it's sine, right? So the derivative of sine is cosine of pi over 2x. Okay. But you see how we have a function on the inside? Hopefully your teacher showed you this. But the derivative of pi over 2x is pi over 2, right? Okay, normally we would multiply by pi over 2, but because it's the antiderivative, we're not going to multiply by pi over 2. We're going to divide by pi over 2. Meaning this is going to become 2 over pi, like this. Okay, so I'll say that again. Because we're doing the antiderivative, right? This is like kind of like the chain rule. We're undoing the chain rule, but right? Normally we would take the derivative of pi over 2x, which is pi over 2, and multiply by pi over 2. But because we're doing the antiderivative, we're going to divide by pi over 2. Okay? And when you divide by pi over 2, it's like multiplying by the reciprocal 2 over pi. So this becomes 6 over pi. So this becomes minus 6 over pi. And sine of pi over 2x. And this go over here, 6x minus 2/3 x minus 1 plus 2x. And we put that minus down there. Okay. Alright, so hopefully I haven't lost you in that. Okay. And we're going to evaluate that guy from 0 to 2. Alright guys? From 0 to 2. So not too difficult, but you just got to be careful, okay? All right. So again, the 6 becomes 6x. This guy, just antiderivative, right? You add 1, divide. This u, right? X minus 1 becomes 1 dx. Doesn't really do anything to it. The 2 becomes a 2x. For the negative 3, cover it up. The antiderivative of cosine is sine of pi over 2x, right? The derivative of pi over 2x is pi over 2, but because we're doing the antiderivative, we're dividing by pi over 2, meaning we are multiplying by the reciprocal, which is 2 over pi, right? Times the negative 3 becomes negative 6 over pi. Plug in that 2, and I'm going to run out of room. All right. Let's just do it the long way. 6 times 2 minus 2/3 times 2 minus 1 plus 2 times 2 minus 6 over pi sine of, if I plug in there, pi over 2 times 2, and that's just the top, right? But I want to show you like how the questions are being developed. You see, that's kind of interesting, huh? But this is doable. This is very, very doable. And now we plug in the bottom. So it'll be 6 times 0 minus 2/3 times 0 minus 1 cubed plus 2 times 0, 6 over pi, sine of pi over 2 times 0. All right, woof, man, that's a long one, huh? All right, well, this becomes a 12. Minus, that becomes 1 cubed 1 minus 2/3 plus 4. And then minus, this becomes sine of pi. And if you get pi, pi is over here, right? So that's negative 1 comma 0. Sine of pi is 0. So all this whole thing here becomes a 0. Okay? Right there. All right. Minus. And then what happens? Well, you end up with 0 here. And this is 0 minus 1, negative 1 cubed is negative 1 times the negative 2/3. That's positive 2/3. Plus 0. And then minus, this is 0. What's sine of 0? So 0 is right here, 1 comma 0. It would be 0. So all of this nicely becomes what? 0. Okay. 0 there, just making sure 0 there. Okay, cool. All right. And then from here, you just do the math, guys, and you should end up with, I think it's 44/3, something like that. Okay. And that's it. That's it. But I want you to see, number one, how, you see, this is 2019, and how the questions are developing, okay? So they're going to ask you area. They're going to ask you volume. And sometimes they ask you like this part C, they ask you to evaluate an integral, but not to set it up, but not to evaluate it. Okay? So let me see if we can just go on to letter B now. Now letter B is an interesting question because you know, we don't really see those too often, but it's not very, very difficult. Okay, and if you guys are able to see what they're going to ask you, you're going to be successful. It says the region R is the base of a solid. Okay, so this is the base, and at each x, the cross section is perpendicular to the x-axis. So you have here, right, some shape that's perpendicular to the x-axis. And it says, has the area of this guy, it says find the volume, right? But it's like, whoa, what happened? I thought they were supposed to give me like a circle or semicircle shape or triangle. They didn't, did they? But actually this question becomes very, very simple. Okay, what do they give me? They give me the area. Okay. Gosh, well, how do I get volume? Right? You do the antiderivative, right? What's area, right? It's a square, right? What happens if I do the antiderivative of a square? It becomes a cubic, right? It becomes three-dimensional. So if you notice, the area, all I have to do is integrate it from 0 to 2 of ax dx. That's pretty much it, guys. That's it. And then they give us, right, a of x is 1 over x plus 3 dx, the integral from 0 to 2. And what does this become? Hopefully you can recognize it. This becomes ln of x plus 3, absolute value of x plus 3. Okay, and we're going to evaluate it from 0 to 2. Now, because my domain is all positive numbers, right, from 0 to 2, this will never be negative, so I can drop the absolute value. So we're going to have ln of x plus 3 from 0 to 2. And then we're going to get ln of 2 plus 3 minus ln of 0 plus 3. Alright, guys. And what is that? ln of 5 minus ln of 3. And that's it. That's it. So remember that, guys. If they don't give you, right, they don't give you the shape, although how do I do it? Very, very simple. Just integrate the area, right? If you integrate a two-dimensional sphere, you end up with a three-dimensional, right? A two-dimensional object, you get a three-dimensional space. All right, and the last one, it says write but do not evaluate. I love those. An integral that gives the volume, you see that, of the solid generated when r is rotated about the horizontal line y equals 6. All right, so this one we kind of got to think about it a little bit. So 6 is 1, 2, 3, 4, 5. 6 is over here. Right over here. Okay, I don't know if it reaches all the way up there, but let's see. If I plug in 1, 1 minus 1 is 0. Now it reaches up to 4. Yeah. No, yeah, it does reach up to 6. I'm sorry. Okay. So this is kind of interesting. All right. Now, when you guys are doing these, I want you guys to think about distance, okay? It's being revolved around this guy right here. This is the line y equals 6, okay? We're rotating it there. So what you're going to do is from the axis of rotation, you're going to draw your radius, okay? From the axis of rotation, all right? It's being rotated about the horizontal line y equals 6. So from there, we're going to go and do it, right? And I'll do it this. So from here, this is my outer radius, all the way down there, okay? Well, what's that distance? Remember, think about distance, okay? From here to all the way to here, what's that distance? Well, it's kind of hard to tell, right? But check it out. From here all the way to here, what's that distance? That's a distance of 6 units, right? 1, 2, 3, 4, 5, 6. From here to here, that's 6 units. Okay, so but I'm going from the axis of rotation. This is 6 units. Well, what's the distance from here to here? Right? Well, you should say it's the function, whatever the y value of the function is. Correct. So 6 plus this distance here, right? But remember, you see how this is below the x-axis? Okay. So this guy is going to be a negative. So this is how you should write it. The outer radius, and that letter is C. Okay, remember, this is going to be the washer method, and I think the washer method comes up 95% of the time. Okay, so you're going to go capital R squared minus little r squared, right? And that's probably how your professor or your teacher taught you. And we're going to go from 0 to 2. Okay. And don't forget your pi there. All right, so what's the outer radius? Well, it's that 6 plus that other distance, but that's the negative because it's below the x-axis. And so what's that function? That's a g of x. Okay, and we're going to square it. Okay, because the outer radius has to be squared. And then minus, now we got to do the inner radius. Well, the inner radius is from here to where? To here. And be careful, what do the students think? Oh, what's that distance? Oh, it's the function, right? Don't I just have to write the function? No. No, 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 no. Remember, when we're talking about the function, we're talking about this distance from here all the way up here. See, from here to here, that's the function. See? From here to here, that's the function. That is the function h of x, okay? From here to here, okay? That's the function. But that's not the inner radius. The inner radius is from the axis of rotation, which is from here to here. That's the distance that I want. Well, how do I get that? You're going to take this whole thing, 6, and you're going to take away this little part here, this distance, and you're going to be left with that little part there. Okay, I'll do it again. So from the axis of rotation, okay, this whole thing is 6. You're going to subtract this distance right here, okay, and you're going to be left with this inner radius right there. You see how a bit of a trick question that is? Okay, so the whole thing, this 6 units minus this guy right here, you end up with that little inner radius. So 6 minus h of x, and we're going to square it because that's what the washer method is, and you're done, guys. Okay, I'll try to make more videos, especially on the volume and stuff like that, but hopefully this helps out, guys, even a little bit. But keep working hard, guys. Remember, work smarter, not harder. Alright, guys, I'll see you guys next time.